Hello everyone, how are you doing today? Well, I'm really missing you. So, anyway, let's start with our class. Today, some of you already saw this presentation, but if you want to go back in order to understand better the problems, then just come back to watch this video. We will start talking about work and machines today, okay? Last week you were working on these key terms, and today I will focus only on these four, which are work, joule, power, and watt. The rest of them we'll be seeing in the following weeks, okay? But I'll let you know. First, imagine I'm walking in the classroom and I want to ask you something. Is work done on a stack of newspapers when you lift them from the floor to a table? So let's say here you have your table and here you have your stack of newspapers, or you have it at the floor and then you pull them upward. Would you say yes or no? Now imagine that same stack of papers, but I am moving through the classroom with them in my hands, moving all along. Will it be yes? Will it be no? Well, let's see then. To calculate work, we depend on two variables, which is force and distance, okay? The amount of force will be given in newtons, and the distance will be given in meters. And work will be a new one that we have not seen before, which is joules. In Spanish, it would be julios, okay? What do I mean with this? For example, we already know that force is given in newtons, so let's say here we have newtons, and we already know that newtons is kilogrammeters over squared seconds. And if you are multiplying times the distance, which is meters, you have meters times meters will give you squared meters, and this is like you have over 1. So you have kilogrammeters squared over squared seconds, which is the same as joules. Now, it's important for you guys to kind of remember it always, that the difference between newtons and joules, we have in newtons kilogrammeters over squared seconds, and joules is kilogrammeters squared or over squared seconds. So it's like when you were playing when you were smaller to find the difference in a drawing. So the difference between newtons and joules would be the squared in the joules, in the meters, okay? So please keep this on mind whenever you are doing the problem so you don't make mistakes in the units. And this is a triangle we'll be using. If you're searching for force, you will divide work divided by distance. If you're searching for distance, is work divided by force. And if we're searching for work, it's force times distance, okay? Now let's move to the next slide. It says, name an everyday task that you would consider to be a lot of work. Okay, here in the first example, you can see that the girl is pushing the boy on the swing. So she's applying a force and the boy is actually moving. So that would be work done. Or this guy moving the lawnmower, he's applying a force and the object is moving a distance. And in this one, you are pulling your books from your backpack and it's moving, the books are moving upward, so there is work applied on the books. Why am I saying this? Okay, it's very important to, in order to have work, sorry, in order to have work done, you need to cover certain distance. For example, have you ever gone to the gym and do the activity that is with the, you carry some things here. You're applying a lot of force, but you're not moving them, okay? So the distance covered, even though you're pulling the pesas, I forgot to call them in English, but here, if you're pulling them from the floor up, but you're not moving, they're static right here. You're applying a lot of force, but they're not moving, so the distance will be equal to 0. So whatever force, let's say 500 newtons times 0, will give you 0 joules. Okay, so that's why it's important to notice in these examples that they are moving in certain distance, right? Okay, so let's see here. Work is done on an object when the object moves in the same direction. And now this is exactly what I was talking about in the first slide. In one of the examples, in the first one, I said that if you were here and you lifted from the floor a stack of newspapers upward, you are pulling, because a force is a push or a pull, right? You're pulling them upward. So the motion of the force is up. Well, the direction of the force is upward. And the motion of the newspapers are upward. So it means that the force and the motion are in the same direction, so there will be work done. But in the other example, I said that I was moving through the classroom with a stack of newspapers on my hands. Okay, so if I'm moving, the motion of the newspaper is moving horizontal because I'm moving through the classroom, but I'm actually pulling them, even though it's not moving, but I'm applying a force upward. So one is moving upward and one is moving in a horizontal way, so they're not moving in the same direction. So work in this one is not applied. Okay, now I want you to observe this image, and here you have these guys pushing the car a lot, and it doesn't matter how much force you apply on it. If the car doesn't move just a centimeter or a millimeter, work won't be done. Okay, let's say in this one, let's say the backpack of the little boy or his lunch bag, the motion is going horizontal and the force is going in a vertical way. There's no work done because the force needs to be in the same direction. Okay, now I want to go really quickly to talk about power. Remember when we talked about velocity, we said that the velocity is the rate at which motion is happening. Well, the same would be with power. Okay, is the rate at which work is done. Okay, so the formula for power will be very easy. I know you've heard power before. In Spanish, power would be potencia, not poder, okay? I will give you a very, very quick example. Imagine if I ask you to write a paragraph of 20 words and I do it in 1 minute and you do it in 30 seconds. Okay, so who would do more work, me or you? Well, we would both actually do the same amount of work because we would both write the 20 words. Just that you would do it faster than me. So you would have more power than me. Okay, and I'm explaining a little bit. But if I tell you, write as many words as you can in 1 minute, and I write 20 words and you write 50 words, who did more work? You did more work because you had more power and could write more words in one paragraph. In 1 minute than me. Okay, more or less. Okay, so I do not need to read it, so you just read the slide, but it's basically what I'm telling you. And this is how we will calculate power. Power is work divided by time. But sometimes in the problems, and we'll see them later on, guys, that work, if I don't give it to you on the problem, you would need to insert it with force times distance. Okay? And the units that will be working, power, will be given in watts. Work, as I said, is joules. And time is in seconds. Okay? So, have you ever heard watts before? Kilowatts? I don't know, in the radio stations if you heard con 100,000 kilowatts de potencia. Okay? So, watts is a very, very small unit. So that's why we usually listen to the word kilowatt, okay? And we also have another common word for power, to measure power, that is horsepower, and it's caballos de fuerza in Spanish. I know you've heard that before. Think about in what, and I would love you to write me a comment in what have you heard the caballos de fuerza. And well, basically of power, that's it. If you have something with more power, you will do work faster. Okay? Thank you, and we'll see the problems in the next video.